you. Excellent. I'll go ahead and introduce myself, and Doug will introduce himself, and then we're going to talk briefly about this picture that's on the screen, and then we'll get into the presentation. As Raymond said, my name is Parry Boogard. I'm with Washington State Task Force 1. I'm a search team manager. I'm also a battalion chief with the Valley Regional Fire Authority, and how our system is set up, a little bit different than a cook, is that ours actually are professional firefighters, professional police officers that then become a USAR team when there's a federal activation. So where there are volunteers that are coming into their system as an NGO, ours is a little bit different, and then when a disaster happens, we actually get federalized, become federal employees as we roll out the door. So that's a little bit of a difference. I'll let Doug introduce himself. I've been involved with tech rescue for 25 years, rescue diver for 20 years, actively involved with that. It's been a passion for me. This continues to be a passion. We've seen the potential. I've been involved with this now since '06 with the development of robot standards and test methods to put robots where we have had to go, in the past, and put the burden upon them. And you look at that risk-benefit factor with human life, and some of the advances we've seen with technology and mapping, and some of the neat things we've talked about in this room, about what the future holds for us. So I'll let Doug introduce himself real quick, and we'll talk about the photo.
I'm Doug Alexander. I'm also with the Valley Regional Fire Authority and Washington State Task Force 1. Like Parry, I've been involved for a lot of years, 25 plus years. Same thing, diving. I've been on the USAR team about 12 years now. Been working with these folks with this since '07. And I'm here for one reason, and that's to save lives. And I hope you understand that that's why you're here too. Because the technology you are going to provide us in the future, and hopefully near future, will save lives, period. Okay? I need you to develop robotics so I do not have to go in that dangerous spot. We can send robotics in there. Okay, so our presentation is going to be based around that, and I just want you to think about that throughout the rest of this today and the rest of this week, that you're here to save lives. You might think you're here for technology's sake, and you are. The bottom line is you are going to help us, the rescuers and responders, save lives. That's important. And I want you to think about that. I think it's top priority.
It's not that you can't go in those places sometimes. It's that you're not allowed to go in those places.
And Balette did a great job talking about the systems we have. The DELSAR system, our acoustic sound, where we put the 6 sensors out, and we use our canines, we use our tech search people. And here's a situation here where this is Hurricane Katrina. I've got the search camera here, which one we talked about. And you see the limitations of that camera. It's actually an extendable probe at the end, which articulates 90 degrees either direction, and that is it. It's got a light at the end. I can communicate with the headset, but that's your limitation, is the reach of that and then that 90-degree angle. So that's what we're looking. You hear us.
Let's just go into that, because
Yeah.
that is a piece of wacky technology that you're using. And the problem with it, first of all, I talked about the illumination, variable illumination. It was the very first lesson they learned. Go or no go. If you do not have variable illumination, it is not going to leave the box. Second is, what orientation are you pointing? When you're in a complex pile and you did stick your probe in there and you did see something of interest off 90 degrees,
Yeah.
what direction is that? All right, that's the first operator interface issue after variable lighting that this thing needs help with, literally.
What's the variable light? Is that because if you're too bright, you're flooding your
Yes, yeah, you saturate yourself. Near field versus far field. They'd like to see far. It might be a void, which is this whole room. They might have come in through this, cut a hole here, or bored a hole here, that's a borehole size, come right in here, and it might be perfectly fine in here. This is 2 levels down. The collapse was a pancake above this. This is the basement. They need to see far, so you need a lot of light. But it also might be a hole that's only as big as the person that's pinned in there, and so you can't have that light too plastic.
And as you see us working across the pile, this is a structural engineer in front of me. The hazmat tech's already been through. We've got a canine over here with a handler. So this is kind of the team, the recon team that's out working, because you've got the engineers leading us in. He says, no go here. So I've got to stick that camera in that window right there and take a look and see if I can see anything. Ideal to be able to put some type of robotic device, toss that through, get a quick scan or a search of the room. Lots of capabilities that we see being developed that we could apply, where we have situations like this. And I'll show you some other pictures of structures that are no-goes. When you see an X on them, you can't go inside of it. So that's where we need to look at other alternatives to come in and do the search. So I've got another smaller camera right here kind of hanging. It's called a mongoose. It's just a very short one where we can do a quick breach to the wall and not have to battle the big long one if you're down inside of a confined space where you've identified with the big camera, you've got an area of interest, the dogs have hit on it. And when our canines come out and they do a hit, we have to have a second dog come and do a hit and alert on that same spot. So that's our confirmatory measure right there. So that's how our system works.
So the one thing missing in this slide is you guys and your technology. Because that guy's told us we cannot go in that building, period. Okay? But you can with your technology. I can throw your robot in there and now we can walk away from that building knowing no one's in there alive because of your technology, okay? That's why this is so important.
So we've already done introductions. Obviously, you can see some of the affiliations that are here. The task force is on the left, Department of Homeland Security, FEMA, and then our home organization. So the Washington State team is comprised, and I think Hal did a great job too. We'll just talk about USAR Environments before we talk about the team. Terrorism, chem, bio, radiological, nuclear, and explosives, sea burning. Natural man-made events. These are the types of things where you're going to see USAR involvement, whether it's a large event, whether it's a terrorist or a natural event that happens. We see earthquakes, tsunamis, hurricanes, tornadoes, lahars, volcanic eruptions, flood events happening all the time. Flood event probably is the most prevalent event in the United States right now is flood events, where you just saw Hurricane Isaac come in and just flood, the bottom part of New Orleans, Packaman's Parish, up to what it looked like when Katrina came through, up to the roof lines, where people were up in the attics having to beat their way out of the attics, being rescued by helicopters again. And other natural events, it's a system that's been set up to accommodate those events that exceed the local resources, the responders' ability to respond, where they're asking for federal help. The National Urban Search and Rescue System in the United States is set up with 28 teams. All of them are WMD certified. So we have 70 members that deploy with a Type 1 Heavy, which I think Philip talked about there, a medium. Our cache that we carry when we deploy is 60,000 pounds. So either we're going by air or we're going by ground. And if we're going by ground, we've got 3 semi-tractor trailers. We got a number of pickup trucks, command vehicles that are going to carry this entire cache across to wherever the incident's at. We have a full second cache, including vehicles, that we keep in reserve. So when Washington State deploys for an event, whether it be Hurricane Katrina, we have a whole nother cache that's there with vehicles. We have a whole nother roster of individuals, so we're immediately back in service locally if there's another event that occurs. We're self-contained for 7 to 10 days. It's just one of those things where you need to be able to go out. We can set up a full base camp. We have full infrastructure. Everything you can imagine we need for 7 days to operate on scene, we've got. We're geographically situated. The teams in the west, central, and the east. I'll show you a map that shows kind of how they are. And there's a national USAR rotation system that we utilize when events occur, where all of a sudden an event has occurred, and I'll show you the chart that identifies which teams are up. The system is set up right now to dispatch the 3 closest teams to any event that occurs. So an event that occurs in California, we'll get 3 California teams probably immediately dispatched out. Then they'll go to the national rotation for any additional teams when they're requesting assistance. We have 2 teams that are internationally certified, like ACUT. Virginia 1, that's Fairfax, and California 2, which is LA County. They're both certified through OFDA, Office for Disaster Aid and Assistance, and there are 2 international teams. A unique thing happened with Haiti was these 2 teams went, and then they also allowed other teams to go that weren't considered international teams. So you had New York and Florida and a number of other teams that went down to Haiti, and I've got some video from New York where they're actually working through a rescue. So I think the important part about this is letting you guys know about our system and then giving you some good video about how our system works, and how we can go out and develop our test methods, and it's a pretty sterile environment. We actually see what we have to deal with as identified. We also go with overhead teams, incident management teams. So before a USAR team goes out, the incident management team is that overhead function, which is that command and control, where they get out on scene, they do all the assessments, they determine where they're going to set up the base of operations, they determine what the limitations are going to be, the number of teams they need to get in. So they come out, they set up, and they're divided up into a white, red, white, and blue. So they're broke up that way. So this is kind of our system. If you up at the top, you see the incident support teams, and they're color coded. So depending on what month, you've got red, white, blue, red, white, blue, red, white, blue. So that's how those folks rotate. Then you can see the USAR teams down below with west, central, and east. And then in the west, you've got all the California teams all the way down to California 8, which is Sacramento, and then Washington Task Force 1 because we're considered a West Coast team. In the central states, you've got everything from Arizona, Colorado, Indiana, Montana, Nebraska, New Mexico, Nevada, Tennessee, Texas, and Utah. So there's 10 there. There's 9 teams on the west. There's 10 teams in the central, and you've got the east teams. Your 2 Florida teams, Massachusetts, Maryland, New York, Pennsylvania, Virginia, 1, 2, and Ohio. So that is how our system. I just pulled this up off of the internet. This is a daily report that comes out through FEMA that identifies the status of the teams. So from this quick look, you can see we've got one team non-operational right now for some particular reason. You got 3 that are conditionally available. So once again, depending on the conditions of the deployment, they may or may not be available, which would affect, this is the rotation model. And not to overwhelm you a little bit, but if you look up here in September, right now Washington is sitting in the 2nd rotation in the west. So if they had an event occur that took 3 teams that were close and they wanted 4 more teams, they'd send the 3 closest teams, and then they'd come down here off this and they'd go, okay, September, you got 1, 2, 3, those 4 teams go with the 3 closest teams. So that's kind of how the system works for that model. This is something that perpetuates on and on and on. So next month, Washington Task Force 1 in October will be first up in the west. So if an event occurs in the west, then we're number 1 for that. If an event occurs someplace else in the east, they'd send the 3 closest team, and then the 4th team would be Washington that would go. And then, November, boom, we come down to the bottom. And it's just this rotation cycle, and it's designed to equalize the work. Some people are going more, but it's a pretty equitable system. Just a real quick overview. You saw the first picture that was Hurricane Katrina. Washington Task Force 1 responded to Katrina. Maximum sustained winds were 175 hours at its peak, and I've got a picture of the hurricane when it's Cat 5. Landfall with 140 mile an hour Category 4 with gusting to 190 miles an hour. A 30 to 40 foot storm surge. We'll show you some shots from down at Gulfport, Mississippi, where you can see what a surge like that does. The temperatures were between 102 to 105, 90% humidity, 1,000 civilians missing, presumed dead, and we're kind of encompassing both the New Orleans theater and also the Mississippi theater. $200 billion of damage. All 28 teams responded. Some were replacing other teams, but they utilized a system where every team was exercised, along with military and multiple state-sponsored water rescue teams assisting Louisiana, Mississippi, and Alabama. Washington Task Force 1 traveled 54 hours from when we got our alert all the way down to a staging area in Dallas, Texas. There we did some training, we did some rehab, and then we were deployed to Gulfport, Mississippi to a water park which became a base of operations, and we operated in Gulfport for 10 days. Katrina formed obviously out here in the Atlantic, came across Florida as a Cat 1 hurricane. It became a Cat 5 on 8 a.m. on 8/28, and it made landfall as a 4. This is a picture of it as a Cat 5 that morning, and that's occupying essentially the Gulf of Mexico right there. And that's before it got a little bit closer and then was downgraded to a 4. Day 1 operations, this is just right off the beach down in Gulfport, Mississippi. What you see very common here is anything that was able to stand had significant damage on the 1st and 2nd floors because of that high surge that came through. When you're standing down here, you're thinking about water being above your head 30 feet as that surge comes in, and it just washed out the initial first floors. So obviously we had some real tough access here to even get up into structures because it had washed everything away. Once again, you start looking at applications with aerial, robotic devices that can do recon, an ability to toss something up into a window that can get in and do some work for you because you have some access problems. And we're looking at doing some triaging here. Other houses were severely wrecked. I mean, this is another one here that actually came through and just literally had itself torn with the whole corner of this place. And once again, the structural engineers come up and say, no, nobody can go in here, it's a no-go. So now how do we get it searched? That's where we rely upon you folks to try and develop some systems that we can deploy that'll work into something like this. And obviously this is some pretty steep stuff here, but there's some other areas within this house you could probably take a look at, or maybe you can get this with an aerial device, you know, a UAV that can come up and take a look and fly around this thing and give us some good intel. This is up in Pass Christian. This is a little bit different type of stuff, but this is all the fallout from the trees. Everything that was coming through with that storm surge, it just washed all of it inland. So what happened was some of these houses became strainers for all the debris. It cleared about the first 3 blocks, just wiped things off all the way to foundation, and all that wood had to go someplace, so it just pushed it inland. So this is just a lot of the debris out of the trees. This is a different type of debris. Once again, a different type of surface for a robot to negotiate. So I know Adam's talking about, you know, the sticks and some poles, but you start to look at this, you start to get your head around kind of the scenarios that we face when we're out working around.
Point out all the holes you would want to stick your head into right there.
One of these, in here, all through here. This is all livable space.
Oh, absolutely.
The house itself is pretty contained.
Yeah.
Anywhere in here, yeah, down below. All these are spaces that we can't go in because the structure engineer said we can't, but you can with your robots. We can toss it right through the window, right in here, like Perry sticking his head in here. Look at the debris over here. Look what's inside this house.
That's literally got a pancake inside of wood debris, you know.
So that's where you come in. We throw something through this window, down through there, operate through, map it for us, cams on there, give us some camera shots of it, and we can determine, is there something in it? Do we see an arm? Do we see a leg? Do we see someone waving at us? You know,
and we've done some talk about subhuman sized void, you know, and that's going to be a space like this. We talked about the things you're going to find, wires and all kinds of stuff that's hanging, because this place is just torn apart. So now you've got to have something that can come through here and negotiate through wires and stuff, you know, whether it's coming in and clipping them, whether it's able to negotiate, push them to the side. You know, how can you recover it? We'll talk a little bit more about this as we get into some video with the ant farm prop. But these are the things where we get probably the greatest value, is where we can't go, because if I put Doug in a hole, if I put him in this thing, I'm going to push Doug in there. Doug's going to go through there and search that. But if I need big enough for Doug, I need something to get in there and do that. The search cam, I might be able to push in a ways, take a look, but there may be another area to the right or left that I can't get to.
yeah, so if you're wondering why we're building the props, or this is building the props, or we're building the test method, your stuff, this is why. Okay, and you see, we got more coming that we're scheming up now. I mean, we aren't trying to be mean or trying to fail what you're trying to accomplish. This is why we need you to get through those things, because we need you to really get through this stuff, if that makes sense. Okay, so the props we build and we test you on, there's obviously a purpose, and the purpose is, if you can make it out there, hopefully you can make it in there with him, okay?
And just another thing, just some of the things we were encountering, obviously because of what was washed in, other houses' contents were washed into other houses because those became the strainers. So all of a sudden we found that we had piles that were 8, 10 feet high of nothing but wood debris, because it just got pushed back and became big strainers for all the debris that had been washed away. So here we've got one of the task force members going through to do a quick hasty search. And one of the questions that had come up when we finally got done was, what was our probability of detection? You know, can you say you're 100% sure when you've got a pile that's 10 feet high that's nothing but wood debris? You can't. I mean, you may be 50%, you know, probability detection, because you can't say you're 100. We rely on the canines. I mean, that was huge for us. But now we're challenged because we have decomposing food. I mean, we've got freezers. We have all kinds of stuff. We have dead animals. I mean, so you have a lot of the odors that are around. And it's challenging to the canines, because our canines are live scent trained. We have a couple that are cadavers, so they actually will, you know, alert on a cadaver. But those are the challenges we face. So that's just the big push that I see with the robotics, is I see such potential. And once again, this is another house, very, very similar to the last one. It was just a lot of them washed off, and all this stuff here that's pushed up is the debris from 3 blocks of homes being taken right off their foundations.
Okay, before you move phone on, so when you're thinking about the live victims,
Yeah.
as opposed to all the other sense, and the dogs are becoming less and less effective, you're thinking about thermal, you're
Absolutely.
thinking about motion of any sort, sometimes color. Because if they dusted themselves off, well, you know, not in this crash, but in an earthquake version, if they dusted themselves off, it means they moved at some point.
Yeah.
And if you see color, it's probably...
Visual acuity, absolutely. You know, I mean, that's real important, because somebody in a concrete collapse covered with concrete dust is going to look like the surroundings. I mean, it's eerie that they blend right in. There's where the thermal scan comes in, where you pick up that heat signature. Yeah. So this is just a few more. Like I said, this is some of the things we encountered, and all these things that I can see application for robotic systems, you know, where they say, okay, this thing is racked really bad, this thing's about to break off, we're not going to put anybody up there, but we got to get it searched, you know. Well, can we introduce a robot that may be able to work its way up or go through a window, you know, take a window out, toss something up there, do a quick search or a scan, and then recover it, you know, and then move to the next place. So,
You see, as a rescuer, I see several major openings that I normally can climb in, but they're saying I can't. So now I can take something, break that window up, grab one of your robots, and like he says, we like to toss things. We toss it in there, it rights itself, it drives around, it looks, it senses, it maps for me, and tells me nothing is upstairs. Because that's very livable up there if you're still in there, okay? I just can't go in there as a rescue person, but you can, okay?
And that's the tragedy. That is the most likely place someone is still alive.
Absolutely.
They went upstairs because the storm surge, just like the tsunami in Japan. The wall war is coming, what are you going to want to do? Get away from it. So you go up because you can't outrun it. That's where our people are going to be. Okay, if you saw any video of this, you saw the rescues, people cutting holes in the roofs, and they're sitting on the roofs waiting for helicopters to come get them. That's what we're talking about right there.
Question about it.
Yes, I wonder whether you can say something about how do you actually get to all these sites? Are the streets and the access paths covered with debris?
A lot of walking. You'll see Perry's got slides.
Yeah, I do, and you bring up a really good point, because when that IST, that incident support team goes out, that's the one that goes out before the SAR teams get there. So what I'm looking at my vision is that you'd have three different types of robotic applications. You'd have an aerial device you could use for recon, because that's going to give you that overhead view, you get it up in the air and get it flying, you know what I mean? So you can see what you've got. Land-based, you know, something that's land-based, it can either get through a window, a subhuman-sized void, and then something submersible. I see a real application for something that's submersible in ROV. So you'd have three types of application: aerial, ground-based, and submersible.
I just wonder, for example, how you would get the equipment
You're
over
back-
there,
you're
because
back-
if
we're
you
gonna-
have to carry it,
Yeah,
we
there
have
are
to carry it.
obviously limits to the weight and
Oh, absolutely,
and what
absolutely.
you can do.
See, that's why it's important.
But
Not
if
only
you can have like a special truck-like device and you have a chance to get, let's say, up to 10 or 20 meters to that, then there could potentially be technology that you have like these huge arms that they use for concrete pumps or something like that. They could just reach from the street basically all the way up to the window, and you don't even need to go all the way through the debris.
Because when we set up our base of operations, like we did at the water park, that's where our base was. We had a forward base of operations we had down in Gulfport, and we had gators that supported us there. So we've got everything we've loaded out of the trucks into gators, and now gators are helping move our equipment around along with the people that are on feet. So
You know what Gator is? Gator is just a utility truck.
Utility vehicle,
like a
one-wheel drive.
four-wheeler type of thing. And it brings up a good point. We're gonna have to pack this stuff around, okay, most of this, as you can tell, we aren't gonna get, so not only do we need smaller robotics to get into these subhuman voids, we gotta carry this equipment with us. So weight-wise is important also, not only for, once they get in there so they don't break through things and risk, you know, people, but yeah, we have to pack this stuff on our backs to get to that spot. Does that make sense? That's why, so weight's
I often
important in a lot
tell
of ways.
them, think about you climbing a ladder to
Yeah.
get to the point of deployment.
So I can throw that robot, put that robot in there, yeah, so it's size is important.
So once again, this is just kind of reinforcing the fact about the challenges that we had. I mean, we had boats up from the marina that have been pushed in. I mean, this is some of the piers. You look at the size of some of these members. It broken all the piers off and taken all the first 3 blocks away. So these are the houses that were left standing, but they're the ones that became the funnel point for all the debris that was pushed up that was just left there. It became a big strainer for it. And all the trees defoliated, completely removed of all their leaves. All the bugs in Mississippi were blowing inland. So, I mean, it was actually hot and humid, but there were no bugs. It was really kind of eerie when we were there. So once again, more vehicles. We actually had a cemetery that had caskets floating up and going inland. We had to check the caskets out to see if anything was in them. You know, popping them up, taking a search camera, popping it inside, and clearing them. So once again, just a little bit more of the wood debris, more wood debris. These are floating casinos that were in the Gulf of Mexico that were lifted up out of the water and brought inland across roads upwards of a couple of blocks. Since then, they've all been rebuilt on the land. hurricane ready and stabilized for, I think, a class 4 hurricane. So, but you look at the size of these things, and this was lifted up on that storm surge and brought inland and sat down. Once again, just you name it, it was in the debris field. Vehicles, I mean, houses, piers, wharfs, I mean, hazmat cylinders, propane tanks, I mean, everything is around there. And what they did do, and you'd add that question, they did come through the Corps of Engineers and do some clearing on streets to try and make access into some areas. So here you can see where they've come through and I've done a little bit of clearing. So that's one of the things they will try to do, is clear that out. And once again, it was just kind of commonplace across the entire Gulfport area was this is where the hurricane made landfall. So everything was gone. The first 3 or 4 blocks and all the rest of the stuff was just pushed to the back. This is the coastal highway. It was completely washed out. I mean, so you're looking, limiting, you know, once again, Doug's talking about the fact we're going to have to pack this stuff in because we don't even have an ability really to put gators in some of these spots because of the way the roads are. Another challenge was with a storm surge, you've got the water returning, right? It comes in, now it comes back out. Well, we had reports of bodies being pulled out to sea, vehicles being pulled out to sea. So now you've got this challenge out here, you know, and how you can address, you know, searching this, and that's where the underwater ROVs kind of come into play is you can deploy those, you know, and you can get them working around. You can take a peek where you have targets of interest or somebody's got a verified sighting of somebody being washed out in a particular area. It gives you a last seen point. So that's kind of that third part of that was the aerial, the ground-based, and the submersible capability. We had shipping containers, we had piers, wharfs. These are cargo containers all swept out to sea. I mean, there was just, everything was brought back out when the water receded back out after it was pushed in with that initial surge. Our last day we were there, we were working in a bayou area where actually huge fishing ships were actually brought up inland upwards of 1/4 to 3/4 of a mile and dropped off. So this is an area, once again, where you have wide area search. So now we're looking at the ability maybe to get something above, and actually an UAV, you know, that can come up here and fly and maybe do some mapping can do a lot to give us, we had to beat the bush, literally, to walk a grid to search this area, and it would have been nice to have some kind of an aerial observation above, you know, that would help you out. Once again, like I said, they're huge ships that are out in the middle of the road, you know, and it's just where the surge left them and dropped them off. We're going to kind of do a quick switch. New York Task Force 1 captured some really good video at the Haiti earthquake. So we're going to do a real quick view of that. Understand they had received a ton of help on this day, you know, back in 01. So September 11th is a very significant day for our system. And you'll hear Mayor Bloomberg talking about the fact of how everybody came to their aid back with the terrorist attacks of, you know, the Twin Towers. And so they felt obligated. And this is going to walk you through the process. It's going to show you how the alert occurs. You know, the guys responding to the cache, getting ready, going through their the physicals, loading up the aircraft and the vehicles, flying, setting up a base of operations, because when you get someplace, you've got to be sustained now for 7 to 10 days. So now they're building their city, their home they're going to be at for a while. While they're building that home, you've got your recon team, you know, you've got your search manager, you've got, you know, all the folks that are going to have to be with him. He's out in the field trying to do some intel and trying to determine some locations where they may deploy the rescue squads. So while one is going on, other functions are occurring. And then we got to try and figure out if we're going to operate in 12-hour cycles or 24 hours a day, or, you know, depending on what your mission requirements are. So this is going to be a concrete pancake collapse. You're going to see it's a live rescue scenario. They received intel from locals about trapped occupants. That's a great thing to have, because that means you don't have to go out and actively find them. I mean, somebody has come and said, hey, I know they're in there, I heard them, you know, so that's great information. New York Task Force 1, Virginia Task Force teamed up, and this is something you find happening all the time, especially internationally, is teams working together. I went back in 2001 to India during an earthquake and worked with a Korean team and a German team as a volunteer on another team, and so we're all trained, we're all here to do the same thing, so it's just neat to see the ability. Talked about caches too briefly. You talked about standardization of your caches for as your team deploys that could. All of our caches are 100% identical. That's a challenge though, so if you want to institute something new, you've got to get it through the FEMA system to get it approved, then it goes system-wide. So those 60,000-pound caches that you find at every one of the task forces are identical. So we're all trained in the same types of stuff, so one team can come in and work with another team, so you've got that interoperability, so it's pretty neat. So let me bounce to this video real quick. I'm going to try and get some sounds. There's some music. I'm going to try and keep it low, kind of up tempo. Volume up here.
Of these buildings, the president and his wife escaped injury, but dozens of other people were killed or buried under rubble.
And with me by phone is Dale Grant of the U.S. Geological.
There's a volume button on top of the speakers.
Oh, there.
The federal government asked us would we send down one of our teams, and so we're dispatching 40 firefighters and 40 cops and some OEM. It's a terrible tragedy in Haiti, and New Yorkers, as you know, remember that the world came to our aid back on 9/11. We want to make sure that we do it wherever we can around the world, whether it's giving advice or giving supplies or actually sending our first responders to help people. The ways the public can.
So this is the loadout that's occurring. So they're in the cache, they're loading up the vehicles or the aircraft. Everybody's got to go through medical screening. So you see they're palletizing here for transport by a C-17. So the briefing they're going to have here with the entire team that's deploying, riding the bus out to the airport.
This is all within how many hours?
Your alert's going to be probably, I think it's 6 hours you have to go. Yeah. They've arrived on the ground now. One of the first things you're going to want to do is they've got to start getting their cache off the aircraft, start getting their base of operations set up, start getting their operational component put together, get the hasty, get ready to get that hasty search going on to get out into the area where the impact has occurred. And this is a lot of work to set this up. You're setting up a small city when we go out and we deploy this stuff.
So is there one team going out doing?
Rescue, our very own local emergency
the
relief
search
first
component will be doing
survivors
those things,
from the
all the rest.
level of devastation in Haiti. Good evening. DeMarco has the night off. Local heroes become heroes of Haiti as they pull 3 survivors from a destroyed grocery store today. The New York team is part of a 400-member search and rescue operation from the United States. Tom Yamas has the very latest from Himani on the Haitian-Dominican border.
Members of the NYPD and FDNY rescued 3 people who were trapped in a grocery store that collapsed during the earthquake. 26 New York City police and fire rescuers worked through the night to pull the victims out of the...
Start looking at some of these things at your pancake, you know, those void spaces where robotics will come into play. Reaching up through a floor to get up into an area above.
NYPD and FDNY helped save more lives, pulling survivors from the rubble. Eyewitness News is the only local TV station with a team of reporters in Haiti. Marcus Solis begins our coverage tonight live in Port-au-Prince. Marcus?
Well, Sandra, early this morning, members of that NYPD FDNY Urban Rescue Squad pulled 3 survivors out of a collapsed supermarket. Then, this afternoon, our cameras were there when a 55-year-old man was pulled out of the rubble of an apartment building. It was, in the words of one team member, miraculous. It took 5 days for Mario Voltaire to be freed from what could have
Look at
been
all the different rescuers that are here,
This
the
morning, a team
multinational
of
nature
Chinese
of this
search and
team.
rescue workers heard signs of life coming from a collapsed 4-story building. Members of the NYPD FDNY Urban Rescue Team were immediately sent to assist.
He was in a void space where he wasn't really pinned, just his leg was. So we worked with the Chinese team, Jimmy and myself. We made the hole bigger, we crawled in there. We were going to start a line on him, IV line in the hole, but it was just he didn't have any good veins because he's so dehydrated.
The rescuers used sensitive listening devices to pinpoint Voltaire's location. Then for 2 grueling hours worked to get the 55-year-old security guard out. It's precise work that can't be rushed, even though every second counts. The rescue workers have come from around the world, all working side by side, which in itself presents some challenges.
The language barrier. When you try to get something like, we ask for like some, even gloves, it becomes problematic.
Despite being trapped for 5 days, Voltaire was dehydrated but otherwise okay, an especially rewarding outcome for the international team effort. I guess when you come down for something like that, this is what you're hoping for, right?
Absolutely. When we come down and help out, and to find somebody in this chaos that's still alive, it really is miraculous.
It's unbelievable. I mean, we're figuring Friday into it, and we started, what was the earthquake, and it's almost unbelievable that he survived down there. So we're very happy, and the team's excited too.
With this, there's another rescue that's going to be coming up, and just look at the building they're working in. When you look at these guys, you can tell they're going to go where they can go. I mean, if a void is big enough to get a body into, these guys are getting there. Usually you're looking at 72 to 96 hours, kind of a threshold where people can survive without water, because after that your kidneys start shutting down, your body will poison itself, you dehydrate and you die. And they had some rescues. This last one I think is upwards of 8 days, where it's just one of those things, it's just miraculous. But you look at what they're working in, it's pretty amazing. And you see exactly where robotics can come into play when you start looking at some of these void spaces, that you can't put a body into. And what if you could put something down there to do some mapping or some search? Canines. Without canines, our team is undeployable. I mean, they're the paramount thing of the USAR system is based upon the canines. saw some UN soldiers that were there. That's called force protection. When we were in Katrina, we had U.S. Marshals assigned to our task force. So task forces didn't go anyplace without some type of force protection. So that's how it works with the U.S. system. I don't know if ECHO does the same thing where you...
Yeah, we had a one where we had military escort.
scan for a boy looking around.
We got notified by 2 locals out there. Heard noises coming out of the drone. So Virginia came to investigate, and through a void, we were able to see partial of a body. So we're able to determine from the noises that about 12 feet from the location of the person.
How does it feel to be here on the week after being working on the job?
Oh, it's incredible. It's an incredible story. It's incredible. It's a gift. It's a miracle. It is.
Working by hand, taking that concrete out by
We're going to
bucket.
survey the area, looking to make some rescues, remove people from extricating in the area. And we got a verbal, which means that they came to us. People came to us saying that they had 2 children trapped in their building. And we had that all day. And we would want to check out every lead, so we came down here. And when we got here, we put a search camera in the hole, and we saw that there was some live victims in the hole.
And what's the meaning to you? Like, it's 1 week since the earthquake, and most people thought there wouldn't be many survivors left to pull out 2 children at once.
What does it mean? It's incredible. I mean, we've never been in an operation like this before. 8 days later is close to survival rate. But it's just a tremendous job by Virginia and New York here.
That's why we need you guys' help.
Unbelievable.
It's that. Like Doug said, that's saving lives.
People at home know about this.
I'd like them to know that New York Task Force is making a difference here. We came from New York City, and we're making a difference. We've got a couple of rescues, and hopefully we'll get a couple more.
Now the current's only pulling me down. We're running over a little bit. I'm gonna cut this video down now. We're just gonna quickly close. It won't be too long, it'll be over. Can you save me from this? 'Cause it's not my time.
So basically, you see what we do for a living, and what we're asking of you is to join our team. Okay, your technology, your knowledge is going to be paramount. What takes us days, our goal is what takes us days now, we want to turn to hours. And what takes us hours to do, we want to turn to minutes, because every minute and every hour counts to save lives like that. Okay, we're asking you to do your thing, to give us the tools so we can do our thing. You become a part of the team nationally and worldwide in saving lives. I hope that video will inspire you a little bit. That lost child there, 8 days. With your help, hopefully we'll find them in 1 day, which in turn we can now find others in between that time. Does that make sense? Understand what I'm saying there?
So the biggest thing is our help is going to be, we're looking at land-based applications. Subhuman-sized void, it's something we've been talking with Adam about. We've been working with this because, once again, if we get dug into a spot, Doug's going to get there and he's going to search it. So these are the areas we can't put somebody into. You'd asked about, what size does it have to be? And it's one of those things where it's going to be kind of relative to the space. Once again, it can be a very long, narrow space. It can be a small space, round space. I mean, we've got, I'll show you a couple things. We've got some potential, some applications. iRobot has first look, which has really showed some promise. We probably, I don't know how long we're going to be able to go over, but I've got a quick video of that. Okay. So these are just some of the things we've seen, some potential. We had a lot of them. This is a small eyeball bot. You can toss up into a window. It can go 360 degrees. It self-rights itself. This is a fiber snake. It vibrates. Satoshi, correct? Okay. And this thing, one of these things you can introduce at the top of a rubble pile, and it's going to vibrate. And it's designed to move forward as it vibrates. Once again, you can work down through rubble and then get down to where you actually have the light. Yeah. And maybe develop comm and some other capabilities within this where you can actually communicate with somebody. This is a top bot. This is I think it's actually evolved now to be a little bit more. It's got bigger wheels, but once again, we're looking at smaller applications that you can put into a space that you can't put a body into. Point man, its ability to stair climb, its low profile. I mean, it may be one of those that might have an application. It hasn't tried the ant farm yet. I'd love to get it up there and see what it could do. And this is the one probably right now that we have probably seen the most promise is this iRobot First Look. It's got the little flippers, it's small, it's able to get through some small spots. The flippers are very convenient to help right itself and work around stuff, so we've seen some potential. Not that this is the only one, but once again, we've only seen what we've seen. So once again, we're empowering you folks to build applications or platforms that are going to be similar to this or maybe even better than this, that will suit the needs we're looking for. Air-based stuff. We've seen a couple of air-based, cover large areas, unobstructed, disadvantages, weather, wind, overhead obstacles, being an operator. Right now, Adam's been working with the iRobot or AirBot with the FAA to get approval to have it used. It's been a phenomenal process with drop testing, and Adam's up to date with that. But once again, there is an application for a UAV that can get up and do reconnaissance and maybe do a payload. Obviously it'd be limited, but can it do air monitoring? Is it IR? Is it a high def camera? Can it map or scan? I mean, there's a number of things. Once again, some of the mission requirements. And then once again, we've seen the Air Robot. And I recently just saw another one called the Avenger that's made from Electron that once again, it's a little bit bigger, but it had some neat capabilities for reconnaissance and mapping and some other things. Payload capability, 10 pounds. I mean, you can do instrumentation, hazmat, air monitoring. But once again, it's a bigger airframe, which then you start looking at FAA requirements, and literally the operator has to be a pilot for something like this. And then submersibles, we've seen some real promise there. I mean, there are some platforms that are good to go right now. I mean, anytime you can put a robot in the water versus a diver like Doug, that's a good thing. The sonar systems they have right now, the Gemini and the Blueview, are so advanced, you can roll one of those things out on the surface, have it beam down, it'll spot the body, and it very clearly, it'll go down and attach with a manipulator. Doug, as a rescue diver, comes down the tether, grabs the body, and he's on his way out. He's not the guy that's at the risk. So, once again, trying to shift that burden to...
this technology is not only to save civilian lives, obviously, it's to save the rescuers' lives also. Anytime you go into the water or into a building like this, you're risking yourself as a responder. Your technology is allowing us not to have to do that as much, and that's a good thing for everybody.
I think Toshi identified they used one of these. This is the SARBot in Japan. Once again, it's got a manipulator down there. UK has taken a look at deploying these UK-wide for drowning scenarios where this thing comes in when the drowning is reported by an operator, and they come out with a sonar, they beam, they identify the body, it can go down, and with that manipulator, it can actually grab a hold, and they can recover it then with the tether. So they're trying to keep divers completely out of the water. And once again, the UK's taking a look at that. Another platform is a video array. It's been the two that we have seen. I think both of them both showed promise. I think some have strengths and weaknesses, but just need to see, these people involved in the process. Our outcome, I mean, we'd love to see approval of the systems into the FEMA system, and I think we're working through we're getting support with not only the responders that are coming to the NIST events, our involvement with the standards and the test method development, but also our after-action reports, which are going through our program manager. I mean, my program manager for Washington Task Force 1 is on board with robotics. So the next step is going to be some kind of a formal USAR work group that'll be for robotics, and that'll be our step to get our foot in the door to where we can actually start to certify this, get some federal funding for participation, and get that step done, because we've done all the homework to get that done. I'm looking, once again, my recommendation would be a land-based, an aerial, and a submersible platform that would be available, possibly in a pre-positioned pod, and maybe start with the IST teams. That's that kind of an overhead team that's going to go, give them those capabilities, let the system sell itself to that group. And once it sells itself to the IST, then it's going to become system-wide for the other USAR teams. Once again, it'll be approved for the cash, they'll approve the funding for them, and that'll be the mechanism to get them out. But once again, it's about little baby steps to get that to happen. I'm going to show you one quick video. This is kind of the end of our presentation. But it's the ant farm, and it's the iRobot First Look. And Doug and I were there the last time we had our event, and they had that in there, and everybody was intimidated because you drop in, you come across, you got to drop down, you come across, you got to drop down, and nobody wants to go in there because you can't recover, your robot. So we've got some parachute cord, and they said, well, what if we just tied some parachute cord to that? We had a guy, tether, hold the cord, and then let the thing work its path and get down. And oddly enough, we got it down to the bottom, and we were able to recover it. So, once again, a very positive outcome. So this is the first lug being tossed up on top. It's got the tether attached here. Doug's tending it over here to the other side, so it's going to come around. So this is the amp farm prop, which essentially is 3 layers. You got an insertion hole that comes across some, it's already in now.
This is the reason we build these props. You saw with the rest of our presentation and the presentation prior to us, why we need the robots to do what they do. This is where we're at now in testing with the test methods. And we're going to develop them even more stringent, if you will, because now you know why. You've seen the pictures, you see what we do for a living, and why we need your technology to do what it does. And this is a good standard way for us to test this method.
So here's our first transition from the initial drop down coming across. Now it's going to transition down to another level, simulated pancake collapse.
Once again, why we need the robots to be hardened. It's going to drop through holes, it's going to hit concrete, it's going to hit rebar. We don't want it to break, we want it to continue its mission.
Go all the way down, man.
So this apparatus is rather clean, is what you're saying initially, for their world. But we're talking about bringing the ceiling down to confine the space a little more, adding some tangling obstacles, like hanging wires or hanging ropes. Even the step fields they would consider clean.
So he's transitioned now to another drop down to the step field below. So the objective was completed. We wanted to get it all the way down to the bottom, having had it drop a couple different times. Now the challenge is recovery, whether or not we can recover it with this little homemade tether that we put onto it. Now tether's a neat thing too, because it can serve a purpose. It can be power, it can be communication. You know, there's so many things you can run through a tether. So make it valuable. So Doug's coordinating now with the operator as he's getting ready to move this up. He's working with Doug to go to up.
Yeah, I think last time it was there too, and it came out okay. Yeah. Good. Oh, right there, Doug. Good, right there. Take it back down just a tiny bit. Here you go.
What works really good with this little guy is the flippers, because it's able to kind of help with those flippers.
You'll
see eventually it's going to be able to get itself up to that level.
Otherwise, you know,
I guess the trick is to give the operator enough knowledge that they don't have to have someone telling them which way to move the flippers.
Well, yeah, eventually
This is a baby step.
Yeah, this is a baby step. This is the first time we're allowing them to look through the plexiglass and see what they're doing. You know, eventually we want to get to the point where it's all zero visibility. You can't see it all. You have to do it all by your own cameras and your own, you know. But here we're proving it works. Tethers work. They're important. This is just a piece of
parachute cord.
Parachute cord. It's string. It's gonna be a challenge because it wants to get in the cracks and everything. Where a tether would be less challenged because it would be bigger around. But the advantage of tethers is you bring power with you. You bring communications with you. You bring a lot of different things with that tether. Not only can you retract and bring it back, you can also bring power and stuff with you. And that's going to be very important because you can see we work for hours and hours and hours at a time. You know, batteries only work in certain areas. We need, a lot of times we're going to need trickle charges and that type of deal to keep that robot running for hours.
Okay. So we made it up from the step field, we're to the second level, and now the objective is to get it all the way to the first floor. Again, the slippers, gets it over.
One positive lesson was to attach it, not to attach your rope tether, but when you have a tether, it makes sense for some people to put it on the tail, where the flippers might be in front, but on your way out, it turns out to be pretty complicated. And having the ability to be pulled up while steering is really important. Getting back out of the holes. All the holes, those are clean holes. Those are extremely clean holes. There were no rebar sticking out of concrete to get snagged on. So there's going to be a lot of steering getting back up and out of holes.
Any questions, comments?
Okay, so thank you so much, Doug and Parry.